All right, so we're going to be hacking a database, of course, legally in this presentation, and I'm going to be breaking down a couple of things. So the first thing is my goal with this talk, and this is important. So I'm either going to bore you to sleep, that's important, or you're going to learn something about cybersecurity and relates to databases and what are best practices, or you will be somewhere in the middle. That's my promise. So it's at the end of the talk, please let me know if I kept my promise. So who am I? So my name is Miguel Solis, and I am a founder and hacker at Huntrix. I've worked in big tech, in government, and my team and I, we organize the New Orleans cybersecurity community. So that's a little bit about me. And I have worked or helped with over 40 organizations and over 30 business units in terms of cybersecurity projects or IT projects. And I've spent about 2,900 hours ethically hacking. So that's pretty cool. Over 70 different applications. That's also pretty cool. And so I have this little cool graph, some label and some other label. But the whole thing is that I've seen some really tiny stuff. You see that little tiny stuff in blue? I've seen that. I've seen some more in the middle. It's kind of green, right? But it's some in the middle. And then I've seen some really, really bad stuff in cybersecurity when it comes to applications. So the applications that I've kind of worked with is AI. So we have a little AI friend here. I've worked in the finance and bank sector. I've also worked with teams in the healthcare sector. When I was in the government, that was my main kind of area that I was focused in terms of cybersecurity and helping their teams. And then I also worked in one of the biggest e-commerce businesses out there and a lot of their different teams across international and markets. So that's a little bit about me. So the reason why I say that is because I've seen some really sus stuff and really, really crazy stuff. So I've seen some things about cybersecurity that I'd like to share with you today. It's a lot. I'm not going to cover everything, but so yeah, that is kind of my main goal, and I'm very confident that I don't say this to talk about myself, but more because you are here listening to me, and I hope that this is worth your time. So I think I'm very confident that this is going to be valuable, or at least, you know, you'll fall asleep and you'll have dreams about databases and being hacked. So why do we even want to talk about databases and hacking them and cybersecurity? So I have three things why we should talk about cybersecurity in the context of databases. The first one is that web vulnerabilities are the hacker's best friend. So people like me who are ethical hackers, we love finding this stuff and we love telling big fancy organization with a lot of money that, hey, I found some critical stuff, some really high stuff. It always makes you feel like, oh, it's awesome as an ethical hacker. But there are a lot more malicious actors out there. There's government-based attackers. There are actually branches of crime that have buildings and have HR that are in other countries internationally that have access to a lot of resources, and they are always trying to, get at web applications, try to get data out of companies, out of teams, and things like that. So they are their best friend. The second thing is that injections, particularly in SQL and databases, because they hold a lot of critical data, they have been a pain for a while, right? So that's the second thing why we should learn and talk about hacking databases and how to protect them. And then the third one is that, data breach equals loss of money, and loss of money equals sad face. So I think that's very, very important. So if you walk away from this presentation, there are three good ones. And the memes and the cat pictures are going to continue, so bear with me. So I got some really cool metrics for the first one, right? The first thing that we talked about is that they are hackers' best friend. And so what I have here is the first metric here that I want to share with you. It says that exploitation of vulnerability out in the open and accounts for 20% of initial access and data breaches seen in 2025. So this is coming from the Verizon DBI report 2025. Their team gathers a lot of data, and they found out that exploitation of vulnerabilities as the vector of initial access in terms of a cyber attack it's seen 20% of the times. That's a big number. That's like 2 out of 10, or yeah, 1 out of 5. So that's pretty. It's pretty relevant for us. And then the same team reports that there's been a 37 increase in ransomware activity versus 2024. So just in 2025, their team, when they came out with this report, well, they're reporting actually on 2024 data, but they reported in 2025. So 2024 report was reporting on 2023. Anyways, they're saying they're seeing a 37% increase in ransomware, and why that is important in the context of what we're talking about is because we know that ransomware is after data, and where our data is stored is some sort of file system, some sort of database, data lake, right? So those are all very, very important. So, and then the 60% of those of breaches seen in 2025 have some sort of involvement in the human element, and so why that's important is because we as developers or DevOps people or security people, whatever, we have some sort of interaction with vulnerabilities, right? So we are part of this kind of ecosystem, and that makes them happen. So, and then the last one is that so for in select breaches, right? So the DBIR team from Verizon, really cool team, for breaches that were non-error, non-misuse, they see that exploitation of vulnerabilities is seen in 42% of the cases. So maybe not initial access, but 42% of breaches have some sort of malicious activity happening with web applications and other kinds of vulnerabilities in relates to the stock, right? So that's the first one. The second one, right? I said that injection has been a problem for a long time. And so right here, we have the Open Web Application Security Project. And if you haven't heard of it, this is like really, really fancy security, really smart, big brain people. They get together and they vote on the biggest vulnerabilities every few years. So we have 2017 and 2021. And what's on the first one? Injection. So it's been a problem even before 2017, but this is like a project where like our industry is trying to determine what are the big priorities that teams need to understand and how to protect against it. And so we see that we have top injection 2017, and then a few years later, the same people from across the world, they say, well, you know what, we're still top 3. So it was taken over by broken access control, which is another type of vulnerability. And then cryptographic failures, another one. But then still there in top 3. So it's very, very important. It's been a problem for a long time. So that's the second reason, right? And then a little bit more on the second reason. So the same team, the OWASP team, they're top 10. So they have, particularly talking about injection, I have this table here, and I'm going to explain this because I'm a big math guy. And hopefully this is where you fall asleep. But in here, we see that the team reports the max incidence rate and an average incidence rate, right? And so why is that important? I'll tell you guys in a minute. But there's a 3%, a 3.37, and a 19, right? So we have those two numbers, right? We have a range, a max and an average. And then we have a weighted exploit and a weighted impact average. And so this is out of 10, right? So they're saying that an injection attack, compared to other vulnerabilities, they have a weighted exploitation, a chance of being exploited 7.25, and out of 10, right? So they rank these across other vulnerabilities, and then we have an impact of 7.15, right? That's important in a second, but I want to show you guys that, and then some other cool one. The total occurrences seen that have been reported to this particular team is a little bit more than 250,000 of total occurrences when it comes to injection. And then CVE is a common vulnerabilities and exposures database. It's like a dictionary of like things that have vulnerabilities that have been disclosed either by vendors or by people like me that are pen testers or bug bounty hunters. And so they tell the teams that develop the systems like Postgres and SQL, the different kind of vendors, databases and systems, and so they report it. Oh, this side, cool. All right. So bear with me on a second. These are numbers that I'm introducing because I'm going somewhere with this. So hopefully we're good. We're good with the numbers, right? Remember the 3%, 19%, and then the 7 and the. This is more like a bonus, kind of icing on the top. So I love statistics. I love it. I am a big stats guy, and I actually think it's one of the best useful maths out there. You can come argue with me after, but yeah, statistics in cyber and risk is super important. And where this lies in this presentation is that we can actually calculate what that means. What does those numbers actually mean in something that we can understand. And so enter the IRIS report. So the IRIS report is the Information Risk Insight Study by this company called Scientia, something like that. I can't say it, sorry. But their team is really cool because they study data on risk, on vulnerabilities, on impact across different organizations. And so I'm introducing this right now because I'm going somewhere with this, right? But this is the IRIS report. This is how it looks like. And so their team actually has this really cool graph. And they say the historical probability of a firm, they call firm, but it's a company, of having an incident in the next year. So they have study data since 2008 all the way to 24. And you can see that the likelihood of a company, from what they study from their sample, having a breach is around 9.3 right now as of last year, right? So that's important. Remember that number, right? That's the likelihood of or historical probability of having one incident. And then they also have this really cool graph, which is a distribution model of reported losses for security incidents from 2015 to 2024. And so you see that cybersecurity, we have this kind of normal graph in statistics. This is what it is. And so we have a median and we have a 95th percentile of what is the cost of a breach in cybersecurity. And that's important. And so we have about a little bit more than $500,000. And then we have 32 in the 95th percentile, so a very extreme case, right? And so that's important. I'll tell you guys where I'm going in a second. So I'm just showing here the numbers that we really care about. And so let's do some quick and dirty stats, right? I mentioned the third reason is that it's all about money sometimes, understanding the money. And you guys are probably technical people, but understanding the money and why it's important and why you have a reason to fix something is important as you talk to other people, right? As you talk to CEOs, your founders, as you talk to other business people, to try and determine what is a priority for you to fix. And so we have this little quick and dirty statistic formula. So we have the probability of a breach times the probability of the injection vulnerability, which we got from OWASP. And then we have the probability of that exploitation actually being weaponized. So very quick and dirty, it's probably wrong, but it gives us an idea of where we're looking at. So that breaks down to these numbers. But the more important part is that you guys saw there's a chance, there's a 9.3 chance, right, every year that the company will have a data breach. And then we have the 3.37 from OWASP of a single application having an injection issue at any given year. And then we have a weighted weaponized or exploitation kind of factor here. So that's the 7.25. And so we get a percentage of 0.23% that will happen. And so we do the same thing with the 19%, right? I'll show you guys where I'm going in a minute. But that gives us an idea of the money, the risk. And that's part of why we're talking about this in the first place. So we go back here, remember, to the little numbers here. So we can actually start to build this little graph, right? So and what's highlighted in what's not highlighted, yeah. But the section here that you can see from the table, so we're checking the incidence rate at 3.37, and then we have our loss amount for both the median and the 95th percentile, and so we can determine that a single application with an injection attack can cost from $1,400 to all the way to $74,000 in the average range, right? So that gives us an idea. And then we also have for the max, right? So if you ever work in a team, there's that likelihood. You're either in between the average or the 95th percentile. And so now you have an understanding that an injection attack can cost the company from $8,000 all the way to almost $500,000. Now, there are some assumptions, right? To me, that looks like a small number because if I'm a hacker and if I successfully exploit your database, I'm going to take all the data out and I'm going to say, hey, give me $100 million for that data back. And this is kind of where we get these numbers, right? Because sometimes hackers, there's a big range of skill sets, right? And some hackers, they ask for a tiny little bit of money, and then some hackers are really good and ask for a ton of money. So that's why the number, that's one assumption, right? There's other key assumptions with this number, right? And why it's not, it's a good base, but don't quote me if somebody's asking you, like, how much does a SQL injection cost? Don't say Miguel said it was $8,000, $1,400. No, it's there's a lot of assumptions here. The first one, for example, is that we are taking historical data. So we have the IRS report, we're taking that, and they're assuming that is a typical org, right? The other thing that we're assuming is that there's a 3.37 chance or 19% chance in between that range that there's an application, one of your applications has at least one injection weakness in a given year. So that's, we're taking into account. And then we're also taking into account the level of what we've seen can be exploited in terms of injections for that one given year for that application. We're also assuming the cost, right? So that we have a big range. So as you can tell from these numbers, as I explained this topic to people, right, is that there's a big range and there's a lot of uncertainty. There's a lot of things that are specific, but at least you guys have a understanding, a little bit of a mind frame of where to start, right? And so not only that, but the IRIS report actually has like multiples. So like there are specific sectors in in markets that are more likely or more attacked by hackers. And so we see that the top one, education, is 1.6 times more likely to have a breach rather than the ones in the left. So you can compare that with our assumption in our kind of money model, and that kind of gives you a better understanding of what we're looking at. But anyways, I probably bored you guys with the numbers and the statistics. I know you guys are here for the fun part, which is how it works. But I think it's important for us to understand the why and those stuff in the money situation, because then we can have conversations with other people that are not technical, right? Like that's the money they speak. The language they speak is money. It's that kind of stuff. So that's why I show it. But anyways, how does SQL injection work, right? And so we have a website, right? We have username and password is a prime example. Every time I have a project where I'm giving the opportunity to enter information, that's called user input, right? And so that user input then becomes essentially, it needs to be processed by your backend or in your application's logic. And so what typically happens in SQL is just, how can I break out of whatever statement is behind there to determine if the application, the server, would result in an error. That's my first test. For example, here, John apostrophe or 1 equals 1 is one of the prime examples that hackers do or ethical hackers do anytime that we can input some information in some sort of field. So I'll break it down a little bit further. So we have our application, and then this is me, right there, or you. And so this is typically what happens. So you have this you have this SQL statement that the backend is going to search from, right? Because you're entering your username, John, and then your password. And so if it was a valid person, you would just put your username and your password, and it matches against the database of records that you have. And if you exist, then if you exist and you got the password right, then you log in, right? That's the logic. The other part is if you exist and you don't get the password right, then you got the wrong password. But in here, what happens when the input, for example, the username input that we're attacking, whenever that is directly being injected into the backend statement, the SQL statement, that's where bad things start to happen. And this is one example out of many examples that we can come up with. So how am I doing on time? I think I'm doing pretty good. All right, so in here we have the select from users where username equals John. So if you can see, I have two quotes in purple. Can you guys see it? All right, cool. So the quotes in purple are what the statement is, how it was built, right? And so the reason why I put the John and then the other apostrophe in this statement is because it's going to escape that last one, right? The purple one after the two dashes. And so what that's going to do in SQL is it's going to make this this logical operator call or, which tells the application that either John has to be true in terms of the username, or 1 equals 1, which always will be true. And it doesn't have to be 1 equals 1. It could be 100 equals 100. But this is a test that a lot of hackers and ethical hackers do on any time you can input data that eventually lands into a database. Can I actually get it to return a bunch of stuff? And so this test here, in this case, is going to result in true, and it's going to give us more stuff than we're supposed to, potentially even logging us in, which we have seen, I've seen myself in applications. Cool. All right, so going into, okay, sorry about that, guys. Are we back? Cool, yeah. All right, so this is true for SQL, but also different types of languages like NoSQL or NoSQL. So this is just another example here of how these attacks occur. My talk is going to focus more on the SQL side. So I just wanted to show you that there are areas that, for example, if you're using AWS or Microsoft and they're managed like databases service, they may have a different type of language or query that you can create. And those have also been exploited by attackers. It's just a little bit different, right? Cool. So we'll do a demo. Cool. This is the cool part. So we have this little shop, right? It's an application. It has a it's like a just a web app. It's showing some shopping, some blogs. So we're gonna be going over it. So all right, real quick, y'all. So if you are enjoying this presentation, my ask is if you could share it with somebody that you know, a coworker, or maybe somebody in this field that works with databases. And that way we can put it into their hands and put this information out there. It would mean the world to us, specifically for me and my team. We work really hard on this presentation and we just want to be able to share with the right people, and hopefully it's helpful or interesting and it sparks some ideas or some conversations. So thank you again. So I hope this goes well. But this is kind of the thing that I wanted to show you guys. As a hacker, this is the first thing that I do in applications and understand how the application works. How does it get its data? Right here, it's using some filters. So if you can see, I move the cursor to the URL because they're using URL parameters to actually get the data from the database and display it to you in the front end. And so you'll see here, I'm just kind of messing around with the with the zoom because I wanted to show you guys. But other things that I do is, okay, let me check other functionality that the application has. So they had a sign-in functionality. So I went ahead in this particular, this is a vulnerable by default application, right? Our goal is to find that SQL injection and be able to exploit it. So I'm here, I'm just testing a couple stuff just because sometimes error messages in logging pages can kind of give me an idea or some sort of hint on what is interesting to me as a hacker, right? So as you can see, it looks like it is, showing me an error message, invalid password. So I was like, okay, cool, that looks normal. I'll come back to it, right? And so I'll go back to the home page because I found anytime I see a URL parameter and it shows in the page as it renders as well, because you see corporate GIFs, I hit corporate GIFs, and then it shows you right there. To me, that's like, ooh, are they immediately like putting that data? And so what I do here is I remove the pets from the category filter, from the parameter, the URL parameter, and I put test, and I want to see, and my test is successful. So I'm like, okay, great. So that means that I can inject things that the developers didn't want me, they're not there, right? So I can start doing some other tests. So the first thing I do is let's do an apostrophe, internal server error. And that's exactly what you want and what the application, if it doesn't have a proper error handling, right? Then it would tell you that there's an internal server error because you broke the quote essentially on the SQL statement, and you caused it to cause a syntax error, right? So that's usually what would happen. That's what I'm showing in here. And so right here, I'm doing a test or 1 equals 1, and that works. And so what that does is that it returns everything, right? It returns everything from whatever database the SQL statement is bound to, right? So so that you see that test is not a category, but I was able to use that, right? So I think I did a couple other tests here. Let me see. Yeah, so I did like a union right here. I'm just kind of spitballing here as I go into this application. I'm doing a union select, and let's see what I do. I think I select off from user, and then that had an error as well. So there's a couple things that we're going to walk through here when it comes to a union select on hacking a database that is important. It's like something that you need to know, right? So I think this is the end of that. So we go into the next one. And so we already know that the URL parameter is vulnerable to injection, and that the injection goes directly into the SQL statement. And then in here, what I'm doing is I'm actually just opening the developer tools, and I just want to check like what kind of data is being returned and in what format. And so I found a table, and as you can see, the table is referenced in that first entry, the high-end gift wrapping, which is the first entry in the website. And so there's two rows there that are being returned on the table. And so that tells me that the database is essentially using 2 columns to return data. And for a union select vulnerability, for you to get data out of the application, you need to have a one-to-one match on what is currently being displayed back, or what the current logic is, and in terms of the number of columns. So right here, what I did, and I'll go back a little bit. So I tried a union select, and then I'm actually using the quotes. So in SQL, if you add quotes, you can actually tell it to render whatever specific text you choose. And so that is a way that hackers can use to test how many columns are there. And I'll kind of show what I did here. So gift union select AAA and comma BBB. And so once I run this, so we see that I was able to inject that into the website to return data that is not in the database, right? So I know that there's 2 columns that I can exfiltrate data from, right? So that's kind of where that gives me like, okay, this looks like it's a union issue, a union select that we can exploit. And so let's see what happens from here. So now, let's step around over here. So now we know that we can use those 2 columns to return data from anywhere in the database schema or structure. From and so I tried. Let's see if there's a third column. So I was like, okay, nope, there's no third column, right? Because it's not returning any third one. And if it tries to return a third one with the CCC, it would fail because it's only using 2. So that's kind of one of the things when it comes to the SQL for union select. So we know that we have only those 2 columns to exfiltrate data from, right? So let's see from here what happens. Okay, cool. So that's the end of this section. And so now we know that there's 2 columns, and we have a union select vulnerability. We're injecting directly into the URL parameter, and now what's next, right? Like as a hacker, it's like, okay, well, I assume that there's some sort of users table that I can try to poke around at. And so I am manually testing in this section here to try to see if I can get data out of the username and passwords table, or the users table, but if I can get the columns for all the users and the passwords. So in here, I'm going to replace the 2 areas with the AAA and the BBB, right? And I'm going to replace it. You'll see here in a second. Kind of pulling the URL on the side here. Let's see. Cool. So now we have username. That's the first thing that I want to return, and passwords. That's the second thing that I care about. So username and password. And then I ran this. Did I run it? Did I run it? I'm thinking right there. This is the demo guide. No, I knew it, and something was missing. I was thinking. So back here, I was like, oh, I'm missing something, right? And that's the thing. When you are having a union, you have to tell it from what table you're going to be returning data from. So that's why this failed specifically. So I'm like, sometimes as a hacker, you try different things, and you go and you fail, and you try another thing, right? So then from here, I'm like, okay, cool. It needs to be from, I need I need to tell it from what table it needs to give me the username and password fields. So let's see. So we have username and password, right? We're selecting that. And then from, we needed that. And then we have users. So sorry, I'm a little slow. It was a little late last time. And we ran it. Let's see what happens. Boom! There you go. Now we get something from the database. So now we have this user, Wiener, administrator, and Carlos, and we have their passwords. So I'm like, oh man. So we were able to essentially use the current SQL statement, which is returning data from the, I think it's just like a post, right? It has a title and it has a description, and we were able to create a union from that to return that data plus the data that we want. And so that is essentially how this attack works. There are a lot of different ways to do SQL injections. This is just one way. And I'll show you another way that I also use, because this is very manual. I'm assuming a lot. I already did this a lot before. And so I knew that there was a users table, and I knew that there was a usernames and password column, right? But what happens if you want to learn more, right? So this is where, wait, there's more, right? So that's kind of where I'm going to show you a couple other tricks when it comes to hackers. And what they do is we use a lot of tools, or we create a lot of tools. So the first one is SQLMap. Really, really good one. It's very hefty. It's been like developed for so many years. It's got like 133 contributors. It checks for Oracle databases, Microsoft, like Postgres. It has like so many different checks. It has like error-based. It has time-based attacks. It has stacked queries, union-based queries. It has a combination of both. So SQLMap is an amazing tool to run against your own systems, for example. In this case, it's super easy to install. I typically have like a Kali box machine, and I use like sudo apt install SQLMap. You guys ever heard of that? Yeah, well, maybe not, but it's just a package manager. So you can install it directly from the GitHub project here. Another good one that actually came to me like about a year ago, and I started using it on my test. It's called Gari. And it's a newer tool. And why I like Gari is because it doesn't have as many of the big the big checks that SQLMap has. So SQLMap takes a lot longer because it has to go through so many different checks. Gari is a little bit more efficient. So I typically run both of these at the same time when I'm doing a test. If I find that there's some sort of area that I can inject input into. And so I usually run the two, and usually one of them is faster and tells me, oh, there's like something here, and I can start developing some sort of attack. And so in this next demo, I'm actually going to do it on the command line on how I run SQLMap. So this is what it looks like, right? And so SQLMap, you have it installed, and then it takes two things. It takes a URL, it takes a parameter, and then it takes a command of what you want it to do. You can set your cookies. In this case, we never needed to set our cookies. But in here I have the URL. So we're working with this lab, and it's the category filter. It has the GIFs, and so I'm using the SQLMap. So I set the URL right there, and then the P flag is for what parameter we want to test against. So we want to test against the category, and then the -dbs tells me. I'm telling SQLMap to tell me what the structure of the database is. So I run it, and this is all the things that it's going to run against that database. So it's going to do it's going to test for SQL and the get parameters. It's going to do MySQL. It's going to do error-based right now. It has like some Oracle right there, some generic inline queries, and then here's thinking on Postgres. Right? It's thinking. I love when it's thinking. So I usually turn this one on and Gari at the same time. I go grab a coffee, some chips, some grapes, and I just wait. And then it comes back here and it says, hey, we found that the application is Postgres, and then the parameter is injectable. It looks like, and it tells you, do you want to keep doing another test? I said, no, let's do just Postgres. And then it says, hey, the parameter category is vulnerable. Do you want to keep testing other stuff? No. And then it tells me exactly the payload, the attack of how I'm going to be able to get data from this database from just the front end, right? I didn't need anything else. I didn't need a username or password. So now I know that there's this payload, the category. So it's using a select PG sleep. So there's actually two vulnerabilities here. One of them is time-based because it's doing the sleeping to determine. And then the other one is the union query. So it's doing all the stuff that we did manually, but it's doing it automatically, right? And so why this is important is that it actually finds that there are 3 databases. There's information schema, PG catalog, and public, right? So I know from Postgres that public is the one that we care about. And so that is when I'm actually going to start enumerating more stuff from the database, right? I'm going to start looking for that public, that database public. I want to see what's in it. So that's where I use in SQLMap. I removed the DBS command and I put D, which stands for database, and I put public because that's the one I care about, and I want to see the tables. So then it starts doing the attack again with those payloads, and then it tells you, okay, it finds that there's a products and there's a users table, right? So now I'm starting, okay, I can either get more information on the products or users. In your case, it could be whatever data that is in that database, right? And so now I want to get information from the users, and I want to get the columns. So this is where I'm using SQLMap to get the -T. I don't know if you can see it, but this -T stands for table, and then users is the table that I care about, and then the columns, and I want to dump it all, right? So SQLMap is going to ask me a quick question here, and it's going to dump it, and it's going to tell me the email, password, and username, all in here. And so this, it tells me the type of kind of field that it's using, right? And then it also tells me the data as I'm dumping it. So this is like a really cool tool that I use all the time, and I think if you're interested, you can also, be able to test it out. Cool. So that's the demo. So how do you prevent it, right? There's a lot of stuff. So cool. The first thing, I have 3 things for you before I go because I have a few minutes left. So the first thing is you mentioned it, right? Prepared statements and or parameterized queries instead of direct concatenations into the statements. It's important. So I have an example here, for example. I don't know if you can see it, but you will usually have something like this where it's string query equals select all from products where category equals input. That's wrong, right? You never want to do that. Never want to get the input directly from the website into your logic, right? It's bad. So instead, what you can do is you can create this prepared statement where you have essentially your statement, right? Your SQL statement. You still want to get the select all from products where category equals question mark. That's where the question mark essentially becomes a variable that then the database is going to have this prepared statement, and it's just going to wait for the data to come in. So anytime that the filter gets changed, it's going to treat that, right? It's going to treat that as an exact match against the database. So it's not gonna take the escape characters or the little like apostrophes, right? It's gonna just do what it was entered, right? So that's a good way. That's what it's called, a prepared statement. And then in some cases, like you said, like the order by, and some other types of SQL statements, is you might have to whitelist permitted input values. So you may have 3 different fields that you only want your users to select from. So just whitelist it, right? And make sure that it's an exact match to what you are looking for users to do, right? Because you wouldn't want an attacker to add a 4th one, let's say if you have 3. So you can whitelist those input values. And then the third one is sometimes you have to then use a different logic. You might have to refactor that specific statement so that you don't mistakenly add a vulnerability that can then be exploited by somebody like me, or I'm an ethical hacker, but there are bad people out there, and so you sometimes have to do this. And I sometimes have had conversations with my developers and teams that I've worked in, just to educate them on the risk and say, hey, you know what, this is not good. Like, we can't have this on our application. We're going to lose funding for it or whatever. You can make the reasons up based on the other things that I kind of talked about, money, right? But yeah, so that's it for how, actually, one more thing. So when it comes to the like SQL injections and stuff, so the bottom line for us is you never want to concatenate anything into it, right? And then you always want to use those prepared statements and parameterized queries, right? So that is one of the best ways to protect against SQL injections. I don't have a lot of time, so I'm just gonna put this up here for questions. You can find me on LinkedIn. Thank you for watching. I hope you enjoyed this video. And if you did, it would mean a lot to me if you can subscribe. That way I can keep making more videos like these and you can stay in the loop. See you next one.